So I will explain about abstract and introduction. So from the abstract, the solar energy has the most potential as a renewable resource that we can use in our everyday life. And according to researcher, the amount of sunlight that strikes the Earth's surface in an hour and a half is enough to power the entire world for a full year. So the solar power is converted from sunlight into electricity via photovoltaics. Indirect conversion via concentrated solar power or a combination of the two. So the concentrated solar power system will focus a wide area of sunlight into a narrow beam using lens or mirror and solar tracking equipment, while using the photovoltaic effect, we use the photovoltaic cell to convert light into an electric current. So in this project, we use two different approaches, which is manual design and using PVC software. The off-grid or freestanding system are self-contained. They are not linked to any electrical grid. So that is the definition of the off-grid. So there are many sizes and often utilized in areas with limited access to grid infrastructure. So for the introduction, as the environment is as the environment is more polluted than before because of human exploitation for natural resource and the invention of new technology, we need to find a more renewable resource, which is sunlight energy, to progress with our daily life. So the research about the sustainable energy system is more developed than before. So many various technology costs have declined and the system has improved. So with this combined, the rate of the technologies and system can be sustainable by an individual. So it is no longer necessary to be isolated from the main grid. So the local resource might provide superior economic circumstances. So in this project, the aim of this project is to design an off-grid photovoltaic system for a residential house to provide a dependable electricity
Okay,
source.
I'm
So
here to present my presentation part, problem statement. It has the most abundant source of energy, which is solar energy. A day's worth of solar energy incident on Earth surface is estimated to be 10,000 TW. According to the report, global energy consumption totaled 17.4 TW in 2015. Every year, energy consumption has increased slightly, with an annual increase about 1 to 1.5%. As a result, off-grid photovoltaic system must be large enough to produce enough electricity to meet households' entire energy needs in all off-grid situations, because there is no grid provide access power. Power consumption should be nominated and kept below the maximum output of the panel and the battery. Objectives: to provide households with dependable electricity, to evaluate specification and power through photovoltaic system.
So I will present for the manual calculation. For the manual calculation, we have 5 steps. Okay, for the step 1, we do the load analysis. This table is a load analysis and the total power consumption is 21262 watt per day. Okay, for the step 2 is a sizing of solar PV panel. Okay, we need to calculate PV power, which is daily consumption over sun peak hour and multiply by 1.3. Okay, we do this and we get PV power is 5528.12 watt or 5.5281 kilowatt. And then we need to calculate number of PV panel, which is PV power over PV panel PR. Okay, the value for PV panel PR is 140 watt, and then we get for number of PV panel is 40 unit. Okay, for the step 3 is sizing the battery bank. Okay, battery bank capacity equal to daily consumption over DOD multiplied by EFF and multiplied by system voltage, and then we get 1042.25 Ah. Okay, and then we need to calculate the number of string, which is battery capacity over battery rating, and then we get 347 for the number of string, and then number of series is equal system voltage over VR. Okay, 48 volt over 3.2 volt, we get 15. Okay, and the number of string is 347, which is parallel connection. Okay, for the step 4 is a sizing of inverter. This is a table for minimum inverter power, and then for the minimum inverter power is 395.1.6, and then we decide to choose 4000 watt inverter. Okay, for the last step is sizing of solar charge controller. Okay, solar PV connection, series and string. Okay, number of series equal to Vmax over VOC, and then we get 11. Okay, number of string equal to number of PV panel over number of series, 36 divided by 11, we get 3.27 or 4, and then number of string is 4 in parallel connection. Okay, ICC equal to ICS multiplied by number of string and multiplied by 1.25, which is equal 15 ampere multiplied by 4 multiplied by 125, and then we get the value of ICC is 75 ampere, less than the ICC rate of the SCC. Okay, this is the figure for PV panel monocrystalline PV rate. Okay, this one, the value for PV panel. Okay, this is the inverter. Okay, this is value for inverter, and solar charge controller, the last one, and this is the value for the solar charge controller. I think that's all from me. Thank you.
So as for today, in this presentation, I would like to share about the simulation of PVCs, which topic given is off-grid photovoltaic system design, which specifically for the residential house. In this project, we have to design a photovoltaic system for Mr. Ahmad Nisfu house, which located in DPHM. So let's proceed to the next slide. So firstly, in our simulation, we used to determine what the appliance or the gadget or the electronic devices that used in the house, which consists of lamp, TV, PC, mobile, ceiling fan, dish and clothes washer, and fridge. That's a basic component that used to in the house. So we already assume the daily use in that house. So in the total that we the total of our assumption is for the daily use for all the components, all the devices in the house is 21.3 k watt hour per day. So this is the system production that we got from the simulation, which is from the available energy we has regenerate 8k kilowatt hour per year, and we just use the energy, the house just use the energy, the 7.5k watt hour per year. So the excess is, which is unused, is just 812 kilowatt hour per year. There are loss of the load too, which is time fraction is just 3.1%, and the missing energy is 241 kilowatt hour per year. So next we go for the characteristic of our PV module and battery. So for the PV module, we choose the generic type. The model is poly 140 watt peak, 36 cell, 10 string and 5 in series. Next we go for the battery. Also we choose the generic type, cells 26650, 3 Ah and 3.2 volt. The lithium ion type. So since it has a small value, so we need a very large of unit, which is 315 in parallel and 32 in series. So the store energy that we can get is 86.6 kWh. So this is the photovoltaic set we use, then sold in the market today, which is monocrystalline solar module PMS 140W, 140 watt. Next is about the battery set is 3.2 volt life for 26650. So this is the capability with retention and system parameter. This is the requirements of the solar panel, or the active area that they required is 50 meter per second, 50 meters squared. But in this simulation, I used to design a bit upper value, because since it has a specific value, a specific itself size. So with just 4 pieces of it, we get 67 area meter squared. So this is the design of the PV field. So since this is the ISO shading diagram, this diagram show that the duration of the sun that can be detected by the PV voltage, PV panel. So basically, this kind of diagram is basically in ratio. So that's all for the data that I got from the simulation. That's all for me. Thank you.
So this is the discussion for our project. Based on the project, the manual design and PVC software we used to simulate electricity production of off-grid photovoltaic system for residential house that belongs to Ahmad Nisfu. Study contained the sizing of the complete off-grid photovoltaic system to decide the required capacity of the PV array, inverter, battery storage, and charge controller to fulfill the required load. And the simulation was carried out based on hourly meteorological data to assess the system performance. The result derived from a series of simulations revealed that the proposed system is able to meet 21.3 kilowatt per hour per day of daily electric load of the case study house for almost the entire year based on 7 kilowatt per hour of total capacity of PV modules and 970 ampere hours of battery storage and with an average solar fraction of about 96.89%. Then the conclusion for the project: the cost of electrifying building in rural area rises as the distance between the grid and the house grow. In situations where the cost of electrification become too high and off-grid PV system can be used. Grid connected and off-grid PV system each have their own set of benefits and drawbacks. One can choose what they wish to do based simply on their needs. The grid-tied system is typically seen in metropolitan and suburban settings where electrification of the area have already been achieved. According to the trend of this is better suited to place where electrification is still being complete and or where the consumer does not want to return the energy generated at his or her end. Because there are so many merchants in the market, the economic component of the system has been discussed in this study. After defining the system capacity, one can look for the best alternative of various equipment based on their budgetary needs. So that's all from our group. Thank you.